Hello everyone, I welcome you all to SVK coaching classes. Do subscribe to my YouTube channel and don't forget to press bell button to get the new notification. In this session, I am going to explain you how to find the solution of system of linear equation by using Gauss Elimination Method. I am going to explain you how to find the solution of a system of linear equation by using a Gauss Elimination Method. So consider a system of equation called a11x1 plus a12x2 plus a13x3 equal to b11, a21x1 plus a22x2 plus a23x3 equal to b12, a31x1 plus a32x2 plus a33x3 equal to b13 is nothing but a system of linear equation. Then this system of equation can be written in a matrix form called Ax equal to B. These three set of equation be a system of equation. So in these three system of equation we have three unknowns, that is x1, x2, x3. So that is what we require to find the solution of x1, x2, x3. Then this system of equation is equivalent a matrix of an equation of the form Ax equal to B. So what is A? Matrix A. Matrix A is nothing but coefficient matrix called A11, A12, A13, A21, A22, A23, A31, A32, A33. Where X is a column matrix called the unknowns, that is x1, x2, x3, and finally the matrix B is also a column matrix B11, B12, B1. Here I have defined what is A, X, B. Then from this matrices we can define an augmented matrix. Matrix is denoted by A is to B. It is denoted by the matrix A value and with that matrix B. After knowing that augmented matrix, to apply the Gauss elimination method, the procedure says that the augmented matrix should be reduced to an upward triangular matrix by using an elementary row operation. That is the procedure. Then that matrix should be converted to a system of equation to get the solutions of the unknowns called x1, x2, x3. Then I want to tell the note here. Consider the note here. We should take care to ensure that the principal diagonal entries are non-zero In case one of the element is 0, then interchange the rows and make it sure that it is non-zero. Consider the problem. Use Gauss elimination method to solve the following system of equations called x plus y plus z equal to 4, 2x plus y minus z equal to 1, x minus y plus 2z equal to 2. Problem they are asking to solve by using Gauss elimination method. So as you know the procedure to solve by Gauss elimination method, so the augmented matrix should be converted to an upper triangular matrix. An augmented matrix should be converted to an upper triangular matrix by using elementary row operations. So first write down the augmented matrix. The augmented matrix of the given system of equation A is to B is the first row. The coefficient matrix is 1, 1, 1. Is what? 1, 1, 1 is to the matrix B is 4. From second equation we have 2, 1, minus 1. Be careful while writing the values of coefficient matrix. It is minus 1 is to 1. From third equation we have 1 minus 1 plus 2, which is nothing but 2, which is equal to 2. Therefore, in case instead of 1, if we have 2, kindly go for interchanging the rows there. Okay, so as we have, and another thing we have here non-zero, so therefore we can make these two elements as 0 by using the first row. So I will apply and row operation. This notation is called as an equivalent matrix. So here I am disturbing two rows, that is R2 and R3. So that's why I am denoting that as a new row there as R2 dash. That implies R2 changes with R2 as R2 minus 2 times of R1. Since the R1 contains 1, so multiply that value by 2 and subtract those two equations, it becomes 0. 2 minus 2. Similarly, 1 minus 1 is 0. Therefore, just R3 dash changes to R3 dash means what? As we are getting new row, so that is named as R3 dash. R3 minus R1. So keep in your mind, when you are applying an operation for R2 and R3, you should not use these two for any other operations. Okay. So here the first row is fixed. 1, 1, 4. The second row and third row is disturbed. 2 minus 2 is 0. 1 minus 2 is minus 1. Minus 1 plus minus 1 minus 2 is minus 3. 1 minus 8 is minus 7. 1 minus 1 0. Minus 1 minus 1 minus 2. 2 minus 1 is 1. 2 minus 4 minus 2. So after this operation I got this matrix. Now I want to make this element as 0, as this leading entry of second row is non-zero, not equal to 0. Therefore I should make this below the leading entry of this element should be 0. I should make this element as 0 by using R2. So I am disturbing R3. So again R3 dash implies R3, as we have same sign here, so the values will be subtracted here. R3 minus 2 times of R2. So it becomes here the first row and second row will be retained as it is. So it is not disturbed. Minus 7. So 0 minus 0 is 0. Minus 2 minus into minus plus 2. So here we are multiplying this value, this row by minus 2. So therefore it is plus 2. Minus 2 plus 2 is 0. 1 plus 6. 1 plus 6 is 7. Minus 2. Minus 2 plus 14. Minus 2 plus 14 is plus 12. Make sure the principal diagonal elements as non-zero. Yes, it is non-zero. And now make sure all the principal diagonal elements should be 1. All the principal diagonal elements should be equal to 1. So by using again row operation, elementary row operation. So as R1 the leading entry is 1, R2 is minus 1. So divide R2 by minus 1 or multiply by minus R2 dash changes to minus R2. R2 dash changes to multiply that equation by that row by, you are going to multiply this second row by minus, and R3 is disturbed here, so R3 dash changes to R3 divided by 7. R3 divided by 7. So you are going to get a new matrix called, the first row is not disturbed. 1 1 1 is to 4 0. You are dividing and multiplying by minus sign. So minus into minus plus 1 plus 3 plus 7. 1 3 7 0. You are dividing the third row by 7. So 0 0 1 12 by 7. So therefore the system of equation will be, therefore the system of equation will be x plus y plus z equal to 4. Name this as equation 1. The second row equation is 0x, so it is 0, plus y plus 3z equal to 7. Name that as equation 2. So the from third row 0x plus 0y, so left out with z equal to 12 by 7. Name that as 3. So from 3 I got the value of z directly. Substitute 3 in 2. Substitute the value of z in equation 2. So you are going to get y plus 3 into 12 by 7 equal to 7. Simplifying this, y equal to 13 by 7. Simplifying this, y equal to 13 by 7. So I got the value of y. Now substituting the value of y and z in equation 1. So equation 1 implies what? X plus 13 by 7 plus 12 by 7 equal to 4. So simplifying this, the value of x is 3 by 7. The value of x is 3 by 7. Therefore the solution for the given system of equation by using Gauss elimination method is x, y, z is nothing but x is 3 by 7, y value is 13 by 7, z value is 12 by 7. So this is the way to find the solution of system of equation by using Gauss elimination method. So now we shall verify the problem of Gauss elimination method by using a calculator called FX991ES. So now see how we can verify by using a calculator. We are going to get analytically the solution as x equal to 3 by 7, y equal to 13 by 7, z equal to 12 by 7. So now let us see how we shall get the verification by calculator or not. So always press clear the memory, press shift 9, clear all. So resetting all. So then go for equation mode, take equation 5. Then 3 unknowns should be given. Out of 4 option, we have the second option as 3 unknown equation called ANX plus BNY plus CNZ equal to DN. Consider that equation. Then press type the augmented matrix. Type the augmented matrix called the first row is 1 equal to 1 equal to 1 equal to 4. Next go with second row, 2 equal to 1 equal to minus 1 equal to 1. Go with third row, 1 minus 1 2 2. So you are going to get the values of x as 3 by 7 is exactly correct. Y as 13 by 7 exactly correct. Z is 12 by 7. This is the way of verifying the problem of Gauss elimination method using a calculator. This is the shortcut to find the solution of system of equation by calculator. Yeah, consider the problem. Use Gauss elimination method to solve the following system of equations. So 3 equation and 3 unknowns. So from this equations I can write the augmented matrix. So what is augmented matrix? The augmented matrix. The augmented matrix A is to B. A is to B is what? A is nothing but coefficient matrix. Coefficients of x, y, z is 3, 1, 1, 2 is to the matrix B is 3, 2, minus 3, minus 1 from second equation, minus 3. From last equation, the coefficient matrix is 1, 2, 1, 1, 2, 1 and the constant value called B is 4. So this is what the augmented matrix for the given system of equation. Now I should make sure that the leading entries of diagonal element should be 1, non-zero. This is the main thing. So I am going to interchange the row called R1 and R2. So this matrix is being interchanged. So I am going to apply an elementary operation called row operation. This symbol is called an equivalent symbol. R1 dash changes with R2, R3 dash. R1 dash changes with R3 dash. Therefore, 1, the whole row should be shifted. The whole row should be shifted. Be careful. The whole row should be shifted. 1, 2, 1 is to 4. 2 minus 3 minus 1. The second row is not being disturbed. 3, 1 2, 3. See, the procedure of Gauss elimination method is to make sure that these mainly to get the upper triangular matrix make these three terms as 0 by using row operation. So therefore, I am going to make these two elements as 0 by using R1. By making use of the row 1, I will make these two elements as 0. So apply the operation. R2 dash changes to R2 minus, as this value is 1 here, multiply this value by 2, you are going to get 2. 2 minus 2 becomes 0. So 2R1. Similarly, the third row, the first element contains 3. The first row, first element contains 1. So this should becomes 3. Therefore, this row should be multiplied by 3 and subtract these two rows. So therefore, R3 dash changes to R3 minus 3 times of R1. So therefore, the first row retains the same 1 to 1 is to 4. So 2 minus 2 becomes 0. 3 minus 4, as this whole row is multiplied by what? The value got 2 here. So minus 3 minus 4. Minus 3 minus 4 is 7. Minus 1 minus 2 is minus 3. Minus 3 minus 8 minus 11. 3 minus 3. This whole row is multiplied by 3 here. So therefore 3 minus 3 is 0. 1 minus 6 minus 5. 2 minus 3 minus 1. 3 minus 12 minus 9. So this is what we have got. Now we have made that the first row leading entry, below that leading entry I have made 0. Now consider the second row, second element should be non-zero. Make the below that leading entry as 0. I should make this term as 0. So by making use of second row, I am going to make that value as 0. So therefore R3 dash changes to, as we have different values here, 7 and 5, as we have different values 7 and 5. So multiply the R3 by 7 and we have same sign. So subtract these two values. So minus 5 times of R2. So therefore I will get a matrix, an equivalent matrix. I am going to get an equivalent matrix. Here these two rows will not be disturbed. The first two rows will not be disturbed. So you are going to retain as it is 1, 2, 1 is to 4, 0, minus 7, minus 3 is to minus 11, 0. So 35, minus 35 plus 35, minus 35 plus 35 is 0. Here this value is multiplied by 7. So minus 7 plus 15. Minus 7 plus 15, 8 is to minus 63 plus 55 gives minus 8. Minus 63 plus 55 gives minus 8. So therefore, now I will make the diagonal elements as 1. So therefore, I am going to divide R2 dash changes to R2 by minus 7. I am going to divide the row R2 by minus 7 and row R3 by 8. R3 by 8. So you are left out with the first row is as it is. The second row is divided by minus 7. So dividing by minus 7, we are going to get it is minus 7 by minus 7 is 1. Minus 3 by minus 7 is 3 by 7. Now minus 11 by minus 7 is 11 by 7. 11 by 7. So divide the last row by 8. It gives 0, 0. 8 by 8 is 1. Minus 8 by 8 is minus 1. Now the given the augmented matrix can be converted to system of equation. The system of equation is what? X plus 2y plus z equal to 4, and the second equation is y plus 3z by 7 equal to 11 by 7. So the last value is z equal to minus 1. So I came to know the value of z as minus 1. Substituting the value of minus z in the above equation. So I will get, you can name this as equation 1, 2 and 3. So substitute 3 in 2. 3 in 2. 3 in 2. I am going to get y. So 3 into minus 1 is minus 3 into minus 1 is minus 3. So plus into minus 3 by 7 equal to 11 by 7. Simplifying this, we are going to get the value of y as 2. Now substituting the value of y and z in equation 1. Equation 1 implies x plus 2 into 2 plus z value is minus 1, which is equal to 4. So simplifying this, we are going to get the value of x as 1. X equal to 1. So therefore the solution is x, y, z is nothing but 1. Solution as 1, 2 and minus 1. 1, 2, minus 1, 2, minus 1 is the required solution by using Gauss Elimination Method.